So I'm going to do a quick example to demonstrate the fundamentals of friction. So if we had a plane here and we had some sort of box or particle or whatever on the plane, we would have a few forces acting on it. First of which is going to be its weight, so straight down, and then a normal reaction straight up. A normal reaction is always perpendicular to the plane, and then we could apply some sort of force going in this direction. So let's say that's thrust, there's a string pulling it or somebody's pushing it in that direction, something like that. Then we'll have friction going in this direction. Friction is always in the opposite direction to the motion. So because it's being pushed this way, the friction will go in the opposite direction, so to the left. Okay, so if we assign some values to this, so let's say the weight is 100 newtons. Okay, and then we say that the friction is limiting. So friction is limiting. What does that mean? Well, it means that if there's any more force applied to the particle in the direction of motion, then the particle will move, or in our case, the box will move. So in this case, F equals T. The friction equals the thrust. Okay? So let's assign a value for the friction. Let's say friction is 50 newtons. Okay? Well, consider the vertical direction. We only have two forces. We have our normal reaction and we have the weight. So they must be equal and opposite because our particle is staying on the plane. Okay? So then R must also be 100 newtons. Okay? We have that F equals mu R. Okay? So R, we already know, that's 100 newtons. F is the friction, which we already know is 50 newtons. And this mu here is the coefficient of friction. So now we can quite easily work out the coefficient of friction by just doing a little bit of rearranging. So mu will equal F over R. Sub in our values, then we'll have 100, sorry, other way around. We'll have 50, because that's our F here, over 100. 50 over 100 is 0.5. And in this case, it doesn't have any units. An easy way to remember that is from the formula. If this is in newtons and this is in newtons, then this can't have any units, because otherwise you would get newtons times that unit. So for example, if you said that this had the unit of meters, then you did meters times newtons. This would have to be in newton meters. But of course, we know that it's not, because we know this is again a force in newtons, so it has no units. Okay, so the coefficient of friction in this case is 0.5. Okay, so an important thing to remember when working with friction is that mu, our coefficient of friction, is always greater than or equal to 0. And the reason for this you can see from a quick model. So there's a particle, there's the plane that it's on. You've got some thrust force taking it this way. It would have some weight. It will have a normal reaction that we'll call R, and then it has some friction going this way. So the reason that it's always greater than or equal to 0 is because if you think about the resultant force, so you would do T minus F for the horizontal direction. If this is positive and friction is less than or equal to mu R, so this is positive, definitely. This, we're not sure yet, but if this was negative, all of a sudden this sign would become positive, wouldn't it? You get T plus F. Okay, so that's suggesting that friction isn't opposing motion, which goes against the definition of friction. Friction always goes in the opposite direction. So if our particle is moving this way, friction is trying to stop it moving that way, so it has to act in that direction. A good thing to remember as well, with a lot of questions, the coefficient of friction is always less than 1, but it's not true for all cases. So for example, if you had, say, a block of ice sliding on a block of ice, they're both two very slippy materials. You'd expect a coefficient of friction less than 1. Whereas, for example, if you had a drag racer with really sticky tyres on a really sticky surface, the coefficient of friction might be greater than 1. So it's an important tip to remember that most times is less than or equal to 1, but it's not true for all cases. So we have a car that has a mass of 1,500 kilograms and it's being towed up an incline at an angle of 30 degrees. And we say that the slope has a coefficient of friction of mu equals 0.4. What would be the required combined force of the tension in the rope T and the thrust from the car, assuming that the car is travelling at a constant velocity up the hill? Okay, so obviously this would be much easier if it was on a flat plane. In this case, it's not. We're at an incline, makes it a little bit tougher, and we need to consider the fact that not all forces are acting in the directions that we want them. I'm going to consider parallel to the plane, and I'm going to consider perpendicular to the plane. What forces aren't in those directions? Well, R, perpendicular, F's parallel, T is also parallel, so it's just W that isn't acting parallel. Notice here, they've quite nicely already drawn this triangle in for us. If this is a right angle triangle, we can then figure out the component of W that act parallel and that act perpendicular. Okay, so parallel of W, what's that going to be? Well, parallel to the plane is going to be this side, which is the opposite, so it's going to be W sine, because it's the opposite, 30. Okay. Next, let's consider what component of it acts perpendicular to the plane. So perpendicular component of W, well, that's going to be this side, which is the adjacent, so it's going to be W cos 30. Okay, so now we can sort of add the two forces on. So this one's going to be W cos 30, and we have another force going parallel this way, that's W sine 30. Okay, so if we consider perpendicular, there's only two forces. There's this component of the weight and the normal reaction. So, because the car is not coming off the plane or through the plane, we must know then that the normal reaction is equivalent to the component of the weight. Okay, so how can we work out the component of the weight? Well, if it's 1500 kilograms, its weight would then be 1500 G, where G is 9.8. So it would be 1500 G, and the perpendicular one, so cos 30. If we work that out, what would we get? We would get 12730.57 newtons to two decimal places. And because the only forces acting perpendicular to the plane are this one and the normal reaction, then this is also the normal reaction because they're equal and opposite. Okay, so what do we need to work out now? How much does the thrust need to be? Okay, well, consider the forces that are acting parallel. We have T, F, and then the component of the weight. So we'd have the T, which is our tension, plus the thrust. Okay, so there's the tension pulling it up, the thrust from the car, and it's moving at a constant velocity, so that means it's not accelerating. So the resultant force must be zero, because F equals ma. If it's accelerating, the mass is always greater than zero, so this will be greater than zero. But because we know that it's not accelerating, then this must be zero, then therefore this is zero. Okay, so then this must equal whatever's going down the plane, which we know is F plus W sine 30. Okay, so we basically just need to figure out what this is. Well, we already know what W is now. W is 1500 G. And F, well, we can work that out because we know the normal reaction and we know that F equals mu R. Okay, so what's mu? This is 0.4. It's told in the question, the coefficient of friction, mu is 0.4. We know that R is this number here. So we can sub everything that we know in here. So we're going to do 0.4 R, again, that number there, plus W sine 30, where W is 1500 G, because that's the weight of the car, not the mass. Okay, so how would we work this out? Well, this will work out to be 12,442.23 newtons. Okay, so remember as well, this is F max here. The reason that it's F max is because it's limiting, the car's not accelerating.